Lesson 9, we're going to practice a new technique in ANSYS, which is analyzing a model which has two elements and two materials. And the materials I'm going to apply for this analysis is going to be steel with elasticity of 200 gigapascals and Poisson's ratio of 0.303, and aluminum with elasticity of 69 gigapascals and Poisson's ratio of 0.334. Let's say we have a plate or a shell hanging from the ceiling, and if this is it, and if I can draw straight lines, okay, these beams that are holding the plate from the ceiling are going to be fixed in this end, and they're going to be made out of steel, and this plate is going to be aluminum, and I'm going to apply a load at the center of 10 kilonewtons, which is 10,000 newtons. The cross-section area of these beams is going to be, let's say, 25 millimeters squared, and the thickness of this plate is going to be 10 millimeters, probably 1 centimeter. I'm going to give length of, let's say, 200 millimeters in here, and 300 millimeters in here, and this height I'm going to give 100 millimeters. So you see, I have beams and I have a shell. That's why I have to apply, or I have to pick two separate elements, a link and a shell. And as you know, each of them have different cross-section or real constants, so I have to define two elements, two real constants, and two materials for this analysis. And how I define these is when I'm about to doing the meshing, and as you will see in the example. So with this, let's go to ANSYS and do the analysis. Okay, we are in ANSYS. The first thing I want to do is to make sure I'm doing the structural analysis, and then come to preprocessor, add edit, and add the first element of link. And since I'm doing a 3D analysis, I'm going to pick a link under a 3D link or 3D model. So I'm selecting SPAR 8, which is link 8. Click apply. The first element is made or added. So I come to shell for the second one, which is going to be a plate, and I'm picking, let's say, this one with 8 nodes per element. I click OK. So I have a link 8 and shell 93. Then I come to real constants, add edit, click add, and the first one I'm going to pick is for link 8. It asks for cross-sectional area. I put 25 and click OK. Then add again, this one for shell 93, click OK, and I give thickness of 10, 10, 10, and 10, or 10 for all the nodes. Then I come to materials, material models, and for the first one I just pick elasticity of 200 gigapascals and Poisson's ratio of 0.303, click OK, and then come and apply a second model, material model, click OK, and do elasticity of 69 gigapascals, and Poisson's ratio of 334. And OK this window. Then I come to modeling, and I want to create some key points in here. In ActiveCS, the first one is going to be at x0, y100, and z0 or z0. The second one is going to be in this coordinate system. Let's switch to a 3D oblique view so that you will see how the key points are being generated. So the next one is going to be at minus 150, y of 0, and z of minus 100. Apply. It's in there. I'm applying a second or a fourth key point. See, it's being generated. And the fifth one, apply, and finally this one. Click OK. So the key points are made for me. Now I go to lines, straight lines. I want to make these lines. And for this example, pay attention to how I'm picking the key points for the next lines. I'm going from 1 to 3, 1 to 6, 1 to 4, and 1 to 5. Also, I'm going to pick from 4 to 2, 5 to 2, 3 to 2, and 6 to 2. You will see what this means when I'm doing the meshing. The next step is I'm going to make some areas arbitrary by lines. So I'm making this, oh, oops. Nope. It's getting a hard, okay. Pick that one, pick these 3 lines and make in our area. Pick these 3 in our area, and finally the final area. But let's plot only the lines because I want to use line sizes to do the meshing, so I'm only plotting the lines. Come to meshing, size control, manual size, lines, and I want to pick these 4 lines and say divide them into 15 segments and 0.2 space ratio. I click OK, and as you see, these lines are divided into 15 sections, but the sizes of these sections are not similar or constant. The ones at the end of the line are smaller than the ones that are closer to the beginning of the line. And that's why I told you to pay attention to how I was picking the key points while I was making these lines. Because initially I wanted to make this mesh look like this, finer at this end and coarser at these ends. So that's why I was picking this key point first and the other key points in the second, to make sure that the beginning of my lines was being placed at node or key point 1, and the end of my lines were at either of these 2 corners of this rectangle. I come here again, pick these lines now. If I can pick this line, which is a little tough. Okay. Because it's getting a little bit hard to pick that line, what I want to do is to come to plot controls, numbering, have line numbers on. Okay, so that one is L or line 1. So I'm going to pick line 1, apply, divide that into, let's say, 8 segments, because the reason I'm doing this is I'm a little bit cautious in here, so that the number of meshes, the number of elements that I will get after meshing will not go above 10,000, so that my ANSYS will face an error. So I'm just dividing that line into 8 segments, and also I'm going to do the same thing with these lines. 8 equal segments, for these lines. And let's pick these 4 lines and divide them into 10 with the segment with the spacing ratio of 0.4. Now my model is ready to be meshed, but before doing the meshing, I want to make sure that the first thing is set correctly. Element type 1, link 8, material 1, and real constant 1 are the things that I defined for these 4 element or lines. So I come to meshing, mesh, lines, and pick these 4 lines, click OK, and those 4 lines are being meshed for me. But as you see, the area is disappeared, so I just come to here, plot areas. So my areas are in here, and in order to be convenient, I'm just gonna come here and turn off the line numbering, and then come back to modeling, to elements, element attribute, change all of these things for the second material. Shell 93, material number 2, and real constant number 2, which was for this plate. Let me make sure if I OK that, yes. And get back to meshing. Areas, free, pick these 3 areas or 4 areas and do the meshing. I can ignore this error because it's probably because of my coarse meshing technique. So my material or my model is ready to be um, uh, loaded. Come here and make sure it's static. Apply structural displacement on key points. Pick this key point and make sure that it's all DOF is 0. Okay. And then I want to add a force on key point in here in y direction of minus 10,000. Okay. My material or my model is ready to be solved. Let's see, I faced an warning. Let's see everything is all right. So as you see, my model is deformed in this direction or in this manner. Come to nodal solution, y direction, and this is the deformation of material of my model in y direction. Again, because my ANSYS is not very good in or is limited in the number of elements that I can generate after meshing, I was a little bit cautious and my meshing is not perfect for analysis. So if you're doing this example in a bare version of ANSYS, make sure that you have a finer and bare meshing in your model. So this is what you can see. Also, you can go to here and see the overall displacement or deformation of your model. Vector plot, let's say, how it will happen. Let's look at it from front. There's a little bit of chaos in here, which probably is the reason of that warning that we faced. And list results, let's see reactions in this end. The loads that we're seeing in Fy is 10,000 as we were expecting, but there are some loads in X and Z directions as well, which are very small, but ANSYS has calculated that for us. Let's pick key points first. Okay, the key point at the center, and then come to here. Hopefully there's a node attached to that key point. Select it and see nodal loads 1000 in Fy, and then nodal solution displacement in y direction is it's pretty small displacement in y direction in that uh, point. The other thing I want to show in here, which I'm not sure if it will be a correct one, but let's see if we can see this model in a 3D representation. So I come to here, click on, and well, it doesn't show that to me, so probably I was a little bit skeptic about this one, which really happened. So I come back and list my, let's see if I can plot my elements and replot displacement in y direction. Also we can see nodal solution, von Mises stresses. Okay, this one is a little bit more uh, symmetric. So basically what you learned in this lesson was how to apply two different elements and two different materials to your analysis, and also do line sizing in lines for meshes, and also with different segment sizes from small to big, where you want where you think is more critical in your model, you can use finer meshing, and where you think it's not very critical, you can use coarse meshing. One thing I wanted to add to this model was gravity, but again, I tested this before, and because of the limitation of my version of ANSYS, the displacement of the model was going above a limited value. But you can also practice that. You can come to solution, define and apply gravity to your model, and see how your model would behave if there was also weight and gravity uh, applied to your model. With this, lesson 9 is concluded.